Hello everyone, and welcome to the Mathmetecher channel. In today's video, we would like to find out the limit of the function f in each of the four following cases. So the first case is when the function f(x) equals the square root of x plus 2 all over x minus 4, and we have to calculate its limit when x heads to the number 5. The second case is when our function f(x) equals cosine pi times x plus 1 over x minus 2 all square, and we have to calculate its limit when x heads to the number 2. As for the third case, it's when our function f(x) equals x minus the square root of x plus 1 over x minus 1 all to the power of 3, and we have to calculate its limit when x heads to positive infinity. And finally, we have the fourth case, when our function f(x) equals the sine of pi times x plus 2 all over 2 times x plus 3, and we have to calculate its limit when x heads to negative infinity. So let's start by the first case. So, as in this case, f(x) equals the square root of x plus 2 all over x minus 4, we will note as capital X, the fraction x plus 2 all over x minus 4. So f(x) would be equal to the square root of capital X. Now as the limit of capital X, which equals the fraction x plus 2 all over x minus 4, when x heads to the number 5, equals 7 over 1, which equals 7, we deduce that the limit of the function f(x), when x heads to the number 5, equals the square root of 7. Now let's move on to the second case. For this case, where the function f(x) equals the cosine of pi times x plus 1 over x minus 2 all square, we have the limit of the cosine of pi times x, that equals 1, when x heads to the number 2, and the limit of 1 over x minus 2 all square that equals positive infinity, when x heads to the number 2. Now as our function f(x) equals the sum of these two functions, which are the cosine of pi times x, and 1 over x minus 2 all square, then its limit, when x heads to the number 2, equals the sum of the limits of these two functions when x heads to the number 2. Hence the limit of our function f(x), when x heads to the number 2, equals 1 plus positive infinity, which equals positive infinity. Let's now move on to our third function. So for this case, where our function f(x) equals x minus the square root of x plus 1 over x minus 1 all to the power of 3, we will note the sum x minus the square root of x plus 1 over x minus 1 as capital X. So our function f(x) would be equal to the cubic power of capital X. Now to calculate the limit of capital X, when x heads to positive infinity, as this leads to a case of an indeterminate form, we will extract the variable x as a common factor from the terms of this sum. So the limit of capital X, when x heads to positive infinity, equals the limit of x times 1 minus the square root of x over x plus 1 over x minus 1 all times x, when x heads to positive infinity, which equals positive infinity, as both of the limit of the square root of x over x, and the limit of 1 over x minus 1 all times x, when x heads to positive infinity, equals 0. Therefore the limit of our function f(x), when x heads to positive infinity, would be equal to the limit of capital X to the power of 3, when x heads to positive infinity, which equals positive infinity. Let's now end this study by our fourth and final case. So for this final case, where our function f(x) equals the sine of pi times x plus 2 all over 2 times x plus 3, we will note as capital X, the fraction within the sign, which is pi times x plus 2 all over 2 times x plus 3. So the limit of capital X, when x heads to negative infinity, would be equal to the limit of pi times x over 2 times x, when x heads to negative infinity, which equals pi over 2, as the variables x in the numerator and the denominator cancel out. So the limit of our function f(x), when x heads to negative infinity, equals the sine of pi over 2, which equals 1. As always, we hope you learned from this video. Give it a like and share it. Subscribe to the channel and activate the notification bell for more. And until the next video, have a great time.